Welcome back, everyone. Houston Math Prep here. We want to talk to you about the change of base formula. It's very important when you're using logarithms for anything that you're aware of change of base, mostly because if you're working with a scientific or a graphing calculator, you probably have a base 10 button and a base E button, right? So you may have just a log button and an ln button on your calculator, and you may be working with some different base that is not base 10 or base E, so you can't use your log or your ln button on the calculator straight away to evaluate something like log base 5 or log base 3. So what we'll need to do is be aware of this change of base formula so that we can actually use those log and ln buttons to evaluate logarithms, maybe to get some kind of a decimal answer for the log that we're working with. So our change of base formula is log base b of x equals log base n of x over log base n of b, and that seems like a lot to stare at right away. So let's break that down. First of all, log base b of x just is whatever you're starting with, right? Let's say you have log base 5 of something or log base 3 of something. So it's a log statement. You have a base, and let's say you don't have a log base 5 key or a log base 3 key on your calculator, and so you need to change this into something you can do on the calculator. So over here, you're allowed to change this into any base that you want as long as your base is acceptable. It needs to be a positive base, and your base shouldn't be 1. Okay, so you can change it into log base 10, so you can use the log key, or you can change it into log base E, so you can use the ln key on your calculator, but you can change it into any acceptable base that you would like. How to change what you started with into what you're going to type in the calculator. The inside of your original log, so notice this was log base b of x originally, so my x is inside of the log in the numerator, and my base is inside of the log in my denominator, and this n is just going to be any base you want. Usually we're going to change those into base 10 or base e, because again, log and ln are on most scientific or graphing calculators, and that will be most useful to us, but we can really change it into any log we really want. Let's work through a couple of examples now where we might use the change of base. So let's say we want to approximate to 3 decimal places this log base 2 of 19, and we maybe don't have a log base 2 button on our calculator. So in order to use our log base 10 button or log base E buttons on the calculator, we'll do change of base here. Now, no matter which log you convert this to, you will get the same answer. So I'm going to convert this to base 10 and base E. So I would say log base 2 of 19. Now remember, what's inside of the log goes in the numerator. So if I change this into base 10, I would just say log of 19 on the top. And remember, the base of my log is what's going to go in the denominator. So that will be log of 2. If I were changing this into ln, log base E, then I would say log base 2 of 19 is equal to ln of 19 over ln of 2, the natural log of 19 over the natural log of 2. Again, we use log and ln most commonly with these because those are the most common log keys you'll see on a calculator. If you type either of these in the calculator, log 19 over log 2 or ln of 19 over ln of 2, you'll get a 3 decimal approximation if you round. That is about 4.248 for either of these. Looking at another one, log base 5 of 3. Again, 3 is not a nice round power of 5 that we know, so I want to change it into something that's not base 5, since maybe I don't have base 5 log button on my calculator. So we'll say log base 5 of 3 is the same as changing to base 10, log of 3 over log of 5. If I were changing this into natural log, then log base 5 of 3 would be the natural log of 3 over the natural log of 5. If you type either of these in your calculator, log of 3 over log of 5 or ln of 3 over ln of 5, you'll get a 3 decimal approximation if you round correctly. That is about 0.683. For those of you interested, we'll show you really quickly why the change of base formula works for logarithms. So if we start with some logarithm with a base that we don't want, so we'll call it y equals log base b of x. One thing we can always do with a logarithm is change it to exponential form. So if we swap to exponential form, start at the base, go across the equal sign and back, that form will look like b to the y equals x. Now, if I take a log of any base that I want. I'm just going to call it n here. So if I take log base n of both sides as an operation, we get log base n of b to the y equals log base n of x, just taking the log base n of both sides. What I can do with this y is I can use the power rule to move it out front now, right? So if we use the power rule on the left side, that becomes y times log base n of b is going to equal log base n of x. So all we did was change the left-hand side by moving y out in front of the log. Now if I want to solve for y, I can simply divide both sides by log base n of b, and that will give me that y is equal to log base n of x over log base n of b. And if you look at what we started with and where we ended, you'll see that that was our original statement at the beginning of the video. Log base b of x is equal to log of another base of x divided by log of another base of b. Okay, that's change of base, everyone. Thanks for watching. We'll see you in the next video.